Well then, let's actually do it. If I gave you a graph that looked something like this. Let's talk about some things with this graph. Where would the zeros occur?
When it crosses the x-axis.
Where it crosses the x-axis, right? This would be a 0. We're talking about real zeros here. So where it crosses the x-axis. Crosses x-axis. Algebraically, so that's graphically what a 0 looks like. Algebraically, what does a 0 look like? When y equals 0, right? And with quadratics, we factored, we set each piece to 0, and we solved from there, and that's how we determined algebraically what the zeros were. But graphically, we can look and we can see where it crosses the x-axis. Does that make sense to everybody? We have found these on our calculator. I do remember doing that with us, right? We have calculated them left bound, right bound, and found the 0. Okay. So really what we're looking for, if we had a table of values here, and I want you to think about this because it's important that you understand not just graphically and algebraically, but also from a table. If I had a table of values here, what is happening? What is changing from the 0? The signs, right? The sign of the function. So the y values go from negative to positive. That's the point where they stop being negative, start being positive, right? That's that change. So that's what's happening. So if you looked at a table of values, let's just say I had, and this won't necessarily go with this one, but let's say I had, well, let's see, -2, -2, -1, -0.5, 1, 1, 2, 5, 3, -1. Okay, let's just say that I gave you those particular values. Where could you conclude that the zeros are happening? Just looking at these.
Between the -1 and the 1.
Between these two, right? So there is a 0 somewhere between those two, and I recognize that because which sign, what's changing? Signs of what?
Both
The y. Well, but the x doesn't really matter because it's left to right, so I'm looking at y, right? It goes from being below the x-axis to above the x-axis, which means if it was below and now it's above, it crossed over at some point, right? So somewhere between the x values of -1 and 1, my graph is crossing the axis. Does that verify here graphically? Mm-hmm. Yes. Are there any more looking at that table? Mm-hmm. Between these two, right? So between the value of 2, and we'll say 3 is way over here. I told you it wasn't exact. But between those two values somewhere, y is going from above the x-axis to below the x-axis. Does that make sense? Mm-hmm. Okay. Now, within these graphs, we have special points. I just feel like we've talked about this, but maybe not. What kind of a function might that be? Well, yeah, even. How do you know it's even just by looking at it?
Because they're both going the same.
Both ends are going the same way. How do you know? Good job. Both ends are going up. Both ends going the same way. I know that's even. I know that even degree, and I know that it is a positive leading coefficient. What's the type? What do you think the type, if you had to guess on this? Quartic. So it's linear, quadratic, cubic, quartic, quintic. Well, because we looked at those examples yesterday on what they look like. So, and we said it would be like quartic. Yeah, quartic. Well, I'll tell you in just a second. There you go. Quadratic, right? Cubic, quartic. It kind of adds another little hump there every time. All right. So we talked about zeros being places where the sign changes. There are also some other special parts here happening, all these places. What's happening there? Maximums and minimums. We talked about this with quadratics, I know, right? What would this be? That's see, we did talk about relative and absolute. This would be. Oh, okay. What is this? Why is it not absolute? Because both ends are going up. This one's absolute minimum. What happens graphically at minimums and maximums?
Sign changes. Well,
change directions, okay? Sometimes we call these turning points or inflection points. The direction changes. I'm decreasing. I stop decreasing and I start increasing. At the point where it changes direction, that's where my minimums and maximums occur. This section is going to be a piece of cake for us.
Okay, and on this test, is there going to be like questions with like, state what kind of degree this is and how you know? Because I would love questions like that.
You'll have some that's a part of it, yeah. All right. Let me give you some. Let's say that this point was -2, 4. Let's say that this point was 0, 10, and this point was 3, 1. Tell me the intervals on which the function is increasing. Use your interval notation. What intervals is the function increasing?
It's from X.
We'll use X to describe it. Go ahead. Not domain, but where is it increasing? So where is the function going up as you move left to right? From -2 to 0. Is that the only place?
And from the range of
Does everybody see what we did? As I trace left to right, am I going up or down? Oh, here's where I start increasing. I start at -2. It goes up, 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 up. It changes direction here, right? So it stops. So it stops at 10, it starts going down, and then at 3, it changes again and starts going up. So I've got 2 intervals there on which the function is increasing.
Why don't you put 10? Because technically it starts at...
I'm using the X's to describe it.
You always use X.
Yeah. You would keep doing the U's and add other pieces to your interval. How about decreasing?
And 0 to 3.
Good job. Yeah, sorry. Do we all see where these are coming from? No. All right, decreasing. Furthest left is always decreasing here, right? Do you see that? I'm going down. As I go this way, this section is decreasing. Do you agree with that? Until I get, this is my point that it changes. From this one to this one, is it going up or is it going down? So it's increasing here. From this one to this one, what direction? Decreasing. And then from here to the end, increasing because it's going up, right? So all the places where it's increasing, between these two, so between -2 and 0, and from here to infinity, so from 3 to infinity. Now all the places where it's going down or decreasing is where it starts, so negative infinity, until I hit 2, and it stops, and then it doesn't go down again until I hit this little piece here, which is from 0 to 3.
And then you resume.
Let me just go over the type of homework problems you have just to make sure. So if I give you this equation, so odd. Okay, let's say f of x equals x to the 4th minus x cubed minus 4x squared plus 1. I want you to graph that on your calculator. You're going to be sketching a graph on your homework. It's going to be a sketch, okay? And I want you to determine the integers between which the zeros occur. So I don't want an actual zero value. I just want you to tell me, that is so dumb. I think I'm going to tell you to find the zeros.
It's a double. So we should find the zeros?
We're going to find the zeros and we're going to find the maxes and mins. So let's do that with this. Let's just make sure we can do it. Instead of going between two values, we're just going to graph it and we're going to add, because we know how to do that. We're not going to estimate between two values. Instead, we're just going to find the actual values, okay? All right, so when you graph it, it's steeper. Yes, find the, definitely. X to the 4th, what did I say? Minus x to the 3rd. I can't type on it. Minus what? Oh, 4x squared. Yeah. So what they were asking you is they were asking you to sketch a graph, and we're going to get to the point where we sketch some graphs based on the maxes, the mins, the zeros, and what happens. But right now, let's do some little bit of analysis. So whenever you calculate it, the 0. Remember, you got your left bound, you got your right bound. So negative 1.4, right? So in between negative 2 and negative 1, if that's what we were doing, but we're not. We're going to say it's negative 1.4. What type of extrema does this have? What type of maxes and mins does it have? What's this first one right here?
Relative minimum.
Relative minimum. What about this one? Relative max. Absolute minimum. Okay. Tell me, let me see if I can annotate on here. I'm going to start tracing in red. Am I decreasing or increasing to start with? Decreasing. Tell me when I stop decreasing.
Now.
Okay. So I'm changing. Tell me when I stop increasing.
So when you do that.
You'll have some questions that ask you for the intervals. I'm decreasing, decreasing, decreasing. What's it doing? I didn't tell it to do that. And it goes on forever, right? So here, my decreasing intervals, I'm decreasing from negative infinity until I hit whatever that minimum value is. And I'm not sure, what did anybody calculate it?
For which one? For which one?
This minimum right here.
Negative 1.1, negative 1.
So until negative 1.1.
Right?
The decreasing, I just said, yeah, and so I'm saying decreasing intervals. And then it picks up where? What is it?
It's 0, and then goes
1.1? No.
That's the other one.
What is this one? What's the maximum here?
1.2,
1.0?
or 0, 1. I got 1.2. That's the
This
line.
one.
Oh, I didn't do that.
It's the y-intercept, is that what you said?
Yeah.
Oh, the line is 1.
So it's 0.
Yeah.
Until, look.
Wait, no, it would be 0.
Yeah, that's 0.
It would be 1.2, right?
I got it's a lion.
The line for the maximum was 1, right?
I'm looking at the x. Remember, I'm using the x.
1.2 for the x.
But does it say e negative something on the end of it?
Yeah.
That's 0.
Oh.
So the whole zero.
It's 0?
So it's 1.
If your calculator says 1 point da 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 e negative something, that means 0. Right.
So 0
That's
comma
a-
1?
So 0. 0 until what? So what is this point?
You want the x or the y?
The x. I'm looking for the x.
1.84.
1.83.
Oh, 84 around.
Okay. Correct. But the point is, these are my decreasing intervals, right?
So of the x's.
Right, we're looking at the x, right? Now if I describe my increasing, which I outlined in blue on there, so I'm going between,
It's 1.1 and 0.
yeah, from 1.1 to 0,
And then 1.84 to...
and then 1.84.
Wait, is it negative 1.1? Or just 1.1? It's negative.
Okay. But we're using the point that, how do you what? They calculated this value. This value right here is 1.84 negative whatever.
So when it tells us to estimate between the years, you want us to list the actual...
I just want you to find them, yeah.
Negative.
So the first section you're going to have in your homework is going to say, determine the consecutive integer values of x between which the real zeros and label them and graph them. I just want you to find the real zeros on your calculator. Then you'll have a section, let's see, where it says estimate the x coordinates of the maxes and mins. I just want you to find them on your calculator. And let's see. That's it. I'm going to add on the... Oh, let's do this real quick. Is it what? Yeah, a little bit, but I mean, you should be able to do it with the knowledge that you already have. I'm going to give you some criteria, and I want you to sketch a graph.
Oh, we've done it.
We have.
Well, I'm still there.
Ah, I'm sorry. I want you to sketch an even degree function with a, and they won't always tell you. I'm just going to say an even degree with zeros at 2, 4, and 7. I'll leave it at that, at 2, 4, and 7. Tell me what you know about even degree. What does that tell me right now? This or this, right? Right off the bat, I know that. And I know that it's crossing the x-axis. 2, 4, and 7.
Technically, you get
Mm-hmm. Everybody should look different on these. Because nobody's going to come up with the exact same thing, right? I am going to make mine happy. Is that even if I stop right there?
No.
Mm-mm. Uh-oh. If the only zeros are 2, 4, 7, that doesn't work. So what can I do? Make the what?
7, 0. Don't make it go all the way.
Does that work?
Yeah.
Yes, that works. Are there other ways to do it? Could you do what, Marshall?
When you could just like flatline and function.
No, because it's not a function, yeah.
Well, it should be a function.
No, you could do that. So yours looks like this today. You did.
Yep.
That's what I did.
Perfect. That's
I
fine
didn't know if
too.
that was right.
Mm-hmm.
It would still be a function, but you just have it over here. So what do you want to do?
You only want 2, 4, and 7. You only want the zeros that's given.